2 weeks ago, we started with our descriptive statistics, and I had given tutorial on how to do or how to make frequency distribution table using the JASP software. It's okay. It's okay, Sovereign. Okay, so when you say frequency distribution table, we will just organize in a table the collected data that you have from your respondents. So we will group them together. Bibilangin natin gano'ng karami ang may score na ganito or score na 1, so on. Galag. Dili kaya. Actually, nga po akong laptop kapag mag-just ko. Hindi naman mag-lag yung laptop ko, pero matagal siya ma-open. Okay. Siguro i-uninstall muna and then i-install ulit para gumana siya. Okay? This one is for the SPSS though. Kasi we have like SPSS, diba, the most common used software for statistical testing. However, our problem here is we need to secure a license first before we can really use the SPSS. Nagalagi hapon. Hindi siguro siya kaya sa laptop or something, puno na ang laptop kaya mag-lag na siya if maraming applications na yung naka-install. Sige, now, pwede din gamitin ng SPSS if you have the crack version of it. The crack version of the SPSS, you can use that also. Pero crack version lang yun na wala tayong license dyan. And in research, we cannot really use that and divulge na we use SPSS in computing na wala tayong license. Hindi kaya rin ang laptop. Sige, lisod na po ilisan ang laptop, no? So, it's okay. Ayaw lang pilita. Okay, measures of central tendency. Okay, when you say central tendency, we will determine the center of the distribution of the scores. Okay, so we have here indicators of central tendency, the mean, median, and mode, wherein the mean is the mostly used measure of central tendency, especially if we have interval na type of data, and we can also use mean for some ordinal type of data. But if there is extreme values, yung meron kayong scores na masyadong malayo, like you conducted a test 1 to 100 and you have someone na ang score niya ay 1, the rest nasa mga 80 plus, that is called an extreme score. So masyadong malayo, we cannot really use mean for that. The mean cannot represent the center of the distribution. So that is the time we will use median and mode. So I believe you know what is the meaning of mean, right? That's the average. So you will just have to get the sum of all scores and divide it sa number of samples or sa number of observations. Again, this is the most common measure of our central tendency. Now we can compute the mean of both the population and the sample. If we conducted a testing involving the whole population, then we will be getting the population mean represented by mu. So again, you just have to get the sum of all the scores and divide it sa number of observation or the number of the population. But most of the researches nowadays, nagsasampling lang tayo, so we'll just get a representative from the population. So most likely ang ginagawa natin is we get the sample mean, and the process is still the same. It's just that you will have here the small letter n as your sample size. So just like this one, if we are going to compute the potency of 10 batches of vaccine, what we are going to do is to just add everything and get the mean by dividing it sa 10 kasi we have 10 batches here. So okay lang kahit wala kayong JASP, you can do this manually. Yung nakakalito lang if masyado ng marami. Okay lang kasi yung 10, add mo lang and then divide sa 10. Pero kung ang inyong respondents umabot na ng 300, murag lisod na siya kaayo. Lisod na siya kayo kuhaan og mean class. So first, wait lang ha. Let me share the screen and let me open an Excel. You can actually do this sa Excel. If nagalag ang inyong laptop or computer sa JASP, let's run it sa Excel. Kay dugay mag-open. I'll just open the JASP also ahead of time kay basi maghulat na pud tag dugay later for the JASP. Asa na to? Oh yeah, manumano jud ang ang Excel. That's the problem with the Excel, manumano ka. Oops. So just copy the table. Ayan, na-open na pala siya. Maghang na ka na. Basta mag-open ko just actually maghang ko niya siya. Pero it's okay. Ayan, na-open na siya. Pag na-open na siya, hindi naman na maghang ang laptop ko. Yung opening pa lang. Okay, I copied everything from my PowerPoint presentation to the Excel. And sa Excel, syempre, di ba, we can just get the average. Sorry. By highlighting this one and clicking the FX. And hanapin natin yung mean. Okay? Kanihang man siya. Ayan. Ito, average. This will be the mean plus. And then, pag i-click mo, wait lang. Click ko siya. FX. This is the function. Then hanapin natin si average here. Okay. Ranging from A2 to A3. And then, wait lang. Ayaw niya. Ay, nawala dahil ang numbers. Function. Average. From A2 to A3. There are more circular references where a formula refers to its own cells, either directly or indirectly. This might cause them to calculate. Ano, may formula ko libutang dere. Wala man. Wait lang. Ulit. Okay. This will be this one. Ayan na. Sige. So this is how you're going to do the average. Mano-mano lang itong sa sa Excel. Ulitin ko siya. Sa ayaw niya kanina. Now you just place here, example, dito mo ilalagay yung mean. Lagay mo muna dyan yung cursor mo and then click FX and then average. We're getting the average here or the mean. I-click mo yan and then you highlight the cells na included doon sa pagko-compute natin ng mean. So from 106.6 to 103.4 and just click OK. It will directly give you the mean. Okay? So yan na yung mean natin for the given set of data. 99.4. 15. Nevertheless, we can really compute for the mean here because as you can see the sets of data, wala ka namang outlier. We don't have extreme values. So the mean will really represent the center of the distribution. So kapag ka hindi center ng distribution yung yung mean hindi makarepresent kasi may mga extreme values, that's the time we get the median or even the mode. The median is literally the center of the distribution. So kung mag-manual computation ka ng median, you have to arrange it first from like highest to lowest or lowest to highest. So ang gagawin mo kung manual computation ng ating median, again, you will have to arrange this. Let me copy. I'm not really that familiar with the Excel. I don't use Excel, but for the sake lang, mali akong pindot. For the sake lang doon sa hindi maka-open ng JASP, copy ko muna siya ha. And I don't know how to arrange this actually. Let me, smallest to largest. Okay, so this one. So we have here, mas taas ang 107. May 107 na ano. Ihanggi. Round off. Okay. So the 106.6 should be nasa baba. Siya yung pinakamalaki. Lagay ko lang siya dito sa baba ha. So ayan, na-arrange na siya from highest to lowest. And then again, when you say median, it's literally the center. So you have to look for the center. Pila ni kabuok? 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If you have an even number of samples, you have 2 here na nasa center. This one. So you have 1, 2, 3, 4 sa taas, 1, 2, 3, 4 sa baba. So silang dalawa yung ating center of the distribution. And if you are going to compute for the median, ang gagawin mo, you have to add the 2 scores at the center. Yan yung 97.9 plus the 99.5 and then i-divide mo sa 2. That will be your median. Again, this one is for the manual computation ha ng median. So 97.9 plus 99.5 divided by 2. The median here is 98.7. That's the manual computation. Again, step number 1, arrange the data from highest to lowest or from lowest to highest, parehas lang yun. And then locate the center of the distribution, literally the center, ang gitna. Okay, kasi sana ito kapag ka-odd number yung inyong number of population or number of sample kasi you can easily locate the center. Pero kung even, just like this one, sample, so you will have first the 2 values at the center, i-add mo muna and then divide sa 2. That's the manual computation. But for the Excel, we can still place here the box sa median mismo and then click the FX. And then hanapin natin si median. So you have here the median. Click OK and then highlight the scores. And then click OK again. And then you will have here the median. I hope you can see it's a screen, 98.7. So we have the same values with the Excel and the manual computation for the median. So as you can see, median is literally the center of the distribution. When do we use the median? If the mean cannot be the representative of the distribution due to the presence of outliers or extreme values. Pero ito kasi magiging representative talaga si mean ng ating scores here since malapit lang naman sila. Okay, the lowest is 93.6, the highest is 106.6. Ibang usapan na yun kung meron ka dyang 2, 3, even hanggang 10, outlier pa rin yung matatawag. That is very far from the 93.6. So hihilahin niya pababa yung mean mo. Na hindi siya magiging representative. So that's the time again we are going to use the median. And then the The mode is the number of score na naulit. May pinakamaraming score or naulit doon sa set of scores mo. Okay? Let's see if we can have the mode here. 93.6, 94.9. May naulit ba na score? Walang naulit, no? 93.6, 94.9, 95.6. Magkaiba silang lahat. So most likely, kung magpo-compute tayo ng mode nito, hanapin natin si mode. Nakalagay dyan ang meaning ng mode, Harry. The most frequently occurring or repetitive value in any array range of data. Yan yung meaning ng mode. Supposedly yung nauulit na data. Pero pag wala kang mode, NA talaga yan. Wala tayong mode kasi wala tayong naulit na data dito. Okay, so that's how we do the computation of the mean, median, and mode using the Excel. Now let's try to have this one sa JASP. The measure sa central tendency ito. Delete ko lang ito lahat. And you can ask question ha, baka hindi siya nasundan. So again, ano nga yung ating process of using the JASP? First, you have to encode all the data sa Excel, but wait lang. Ayan. Wait. Pinindot. Lutang lang. Ayan. Again, you have to save this as CSV. So, lagay ko lang siya sa farm stat. Ha? Para madali ko siya makita later. Nagtutuyok na siya. Okay, and then again, pakihanap ng CSV. Wala po nag-antipara. No? Ayan, comma delimited. And then let's just name this mean, median, and mode. And then again, let's save this. Kasi pag hindi naka-CSV format class, hindi yan siya mahahanap ni JASP. Okay, so let's transfer sa JASP. Let's have this one. Okay. And then, paano nga yung JASP? Diba dito tayo mag-start sa left side, upper left side. And then we will be opening the file. So, I place that one sa folder ng pharmaceutical statistics. Tatlong letter M yun. Ayan. And then open. And the data will be imported here. Now we have here the batch. Check natin yung type of data. So naka-ordinal ito. Bakit naka-ordinal? Actually, wala tayong data. Wala tayong data here. Actually, pwede din siya ordinal kasi representative lang naman itong mga numbers na ito. Ito class scale talaga siya. Okay? Now we are still in the descriptive statistics. So we will click descriptive. And then, itong potency yung kailangan natin kunan ng descriptive statistics. So I will just transfer it there sa variables and automatically it will give you the mean. So the mean is 99.15. Okay, 99.15. We have the same mean no sa Excel and sa manual computation. And then you have the maximum and the minimum value. If you are looking for the median and the mode, we can click the statistics here and just look for the median and the mode. We have here the central tendency. Just click the median and then automatically it will appear in the table. So you have here 98.77. That's the same with the result of the Excel a while ago. And if we click mode, wala tayong mode. Actually, nagbigay lang siya ng value dyan. Pero wala talaga tayong mode here kasi wala namang naulit na score. Okay, that's how we do or that's how we get the mean, median, and mode using the JASP. All we need to do is to properly and correctly encode all the data in the Excel and then save it as CSV. and then open it, import natin siya sa JASP, and then descriptive statistics muna tayo. So automatically, the table will give you the mean, but if you are also looking for the median and mode, dito natin siya makikita ha sa statistics on the left side, and just click the box for the median and the mode, and then automatically mag-a-adjust ang table. Papakita niya din sa'yo yung mean, yung median and yung mode. And then last time, I think I told you that you can copy this table. So just click copy and paste it sa Word or kung saan nyo man siya ilalagay. Okay? So dalawang options na yun. Actually, tatlong options. You can do the manual computation if konti lang yung data natin. But you can use Excel if your laptop really cannot accommodate the JASP software. Or you can use the JASP software mismo kung okay lang sa gadget mo. Any question about the measures of central tendency? Most of you will be using the mean, so we don't have problem. Wala naman na sigurong masyadong outlier. Depende sa data nyo kung may outlier kayo. Your data will not be normally distributed by that time pag may outlier kayo. You cannot use the parametric test. Walang question? Sure na? Una-una na magkatulog diha o nag-una-una na magpanihapon? Sana all. Wait lang ha, i-close ko lang ito ulit. And then, let's move on. Ay, mag-open ako ulit ng JASP. Mas mag-hang kasi ang JASP kapag marami ka na masyadong in-open. So you have to close everything first. Feeling ako natulog. Natulog na ang bandiya ba? Una-una nagkatulog. Kulang ba nagtulog basta estudyante? So, na-brown out. Okay. Okay na tayo sa measures of central tendency. We will just look at the center of the distribution ng good. Yung test nyo, water district, presence and absence lang po. Yeah, you can have the frequency distribution table, and your frequency distribution table is like this. You get my point. Ilang testing yun? Ilang testing nga yun? Presence and absence. Ano lang siya? Yes or no? Or merong ano? Like amount ng number of colonies or so on, ang brownout sa pulumulok. Okay. Presence and absence lang talaga. Siguro, ilang ano yon? Ilang water station? Wala silang tanan no, brownout. 20 water stations din. Isang testing lang sa isang water station or isang water station tapos 20 testing. Hindi kasi ako familiar with your methodology. Ko memorize. Sige, clarify muna natin para tama yung table na magagawa natin. Isa lang siya. Okay. So that is just a pure like simple table lang talaga ito. So we have here presence and then absence of bacteria, tapos station na agad dito. May number of colonies ito or wala? Kaya sa pusa. Okay. Let me back read, baka may na-miss ako. lang. Kung may number of colonies, so like ano lang talaga, presence and absence. Ana lang, wala day mo ano like wala mo quantitative data and wala mo like statistical testing na ano, purely descriptive pala itong study nyo. Purely descriptive lang talaga ito. Like for example, station 1, merong presence. Like magiging check lang siguro ito. Actually, you can just have the total sa baba kung ilang water station ang may presence of the bacteria. For example, 10 din yung sa absence, may na walang growth ng bacteria, and then that's it. Yun na. Wala nang statistical testing. Wala ding mean, walang mode, walang median, wala din tayong standard deviation kasi isang testing lang talaga bawat station. So ito lang yung magiging table nyo, very simple one. Purely descriptive ang study ninyo. Ano lang, yung procedure lang may experiment na involved, pero purely descriptive siya na i-describe lang ninyo kung gaano karaming stations in General Santos City yung may presence ng certain bacteria na hinahanap ninyo, ilan din yung wala. Ganun lang. And explain nyo na lang in the discussion kung ano ba talaga yung standard. Okay, kung presence and absence lang pala. Akala ko kasi meron siyang yung colony count. Tapos ang sa water district, presence and absence lang talaga yung bibigay nila. Mas mahal, mga pila buton. $950? May colony count na, no? 950 times 20. Mataginting na 19,000. Wait lang. Ang standard sa water na nahanap niyo sa RRL ninyo is like may certain colony count or like wala dapat talaga. Ano yung standard na nakita para sa tubig? As in walang E. coli per ml. So presence and absence. Okay lang ito. Alam ni Ma'am Yas ito? Alam ni Ma'am Yas na ganito. Sige, kausapin mo lang si Ma'am Yas. Okay lang. Pero yung table niyo for your, kung ganito lang kung ganito lang yung data ninyo, I mean, hindi din siya matatawag na frequency distribution table, just simple one. You just have to list down the stations. You just don't need to mention the name ha, kay wala man tanan ng hid sa ilahang magtesta sa ilahang water. And then check na lang kung may presence ba ng E. coli or wala. Statistical tool, wala na ding walang mean. Ano lang siguro, sum lang yung sa central of measure tendency, sum ng merong presence and sum ng merong absent talaga yung E. coli. Ganun lang. Tawagin na natin siyang frequency distribution table. Pwede ding percent. After makunin yung sum, pwede ka din magkuha ng percent. Like how many percent ng total na station ang nagkaroon ng presence ng E. coli. Ano percentage? Yes, this one is a simple research, but this one is expensive. Oh yeah, pwede mo din pala yan. Okay. Pwede pala may barangay. Pwede din pala ito, frequency distribution table and percentage. Kasi hiwalay naman pala siya per barangay. Okay? Okay, anything else? How about the other groups? Do you want to clarify something? Malay? Sige, kung wala, let's have the measures of variation. So in research, you will be expected to have a lot of data, right? Numerical data. Sa experimental na study, you will be asked to perform trials or replicates. So again, marami tayong data and we have to make sure that the data na makokollect natin are precise. So they will be close to each other. Walang outliers. Yung sinabi ko kanina na we cannot use the mean if you have outliers or extreme values. So in order for us to really know whether our data are precise or not, we are going to compute or we are going to use these measures of variation. First, we have the range. The range is just very easy. You just have to identify the lowest score and the highest score. Ano lang. So again, the range, this is capital letter R, is equal to the highest value or the highest score minus the lowest score, the lowest value. So example na mo'y like inyuhang test is from 1 to 20. So naamoy student na nakakuha og 20 tapos naapoy 5 lang iyang score. So this is the highest, this is the lowest, the range is just 15. So this is the distance between the highest or the largest value to the lowest value for the given set of numerical data. That's the meaning of the range. So the higher the number there for the range, the more na masyadong malayo, hindi precise yung data ninyo. Meron tayong outliers if masyadong malaki yung range value ninyo. So meron tayong ungrouped data. Kung isang group lang talaga ha, diretso na yun highest value minus the lowest value. Pero there are instances na yung research nag-group together, ginag-group together yung scores. So like we have one group here na set of scores ito, and then another group here, another set of scores, then ito dito. Now, what we are going to do is to get the upper boundary of the highest class interval. So example, na-group tayo, dito yung mga matataas ang example grado. Ito yung mga grades na 80 to 90, tapos lagyan na natin hanggang 100. Ito naman yung grupo na ang grado is 50 to 80. So ang ginagawa, first you have to know the upper boundary of the highest class interval. Ito yung highest class interval natin, yung mga matataas ang score, and i-check mo muna kung alin sa kanila or ano yung pinakamataas na score sa grupo na ito. So kung may person ka na 100 talaga yung score, so yan yung magiging UBHCL. That's the upper boundary ng highest class interval. And then dito naman sa LBLCL, that's the lower boundary of the lowest class interval. Hanapin mo din yung pinakamababa na score here. So for example, may nakakuha ng 50. So this is 100 minus 50. The group range is 50. But sa interpretation, ganun pa rin. The larger the number of the range or the value of the range, the more na hindi precise yung data mo. Okay? Kasi malayo yung agwat nila, yung distance nila with each other. So dapat para masabi mo talagang precise na your collected data is nag-a-agree sila with each other, kailangan mababa din yung range. So for example, the range of this set of scores, marami tayong scores here. Pila ni siya kabuok? 30. Now, since hindi ito group, automatic ito class, hindi naman siya naka-group. You just have to identify the highest score, that's 10. And what is the lowest score here? The 3. So this is the lowest score. So the range here is 7. That's how you get the range. Even if we don't use just here, we can easily identify the highest score and the lowest score. Unless na lang kung masyadong marami yung data mo. Okay? Kung naabot na siya 500 kabuok, murag malibat na pangita sa lowest value and sa highest value. But nevertheless, this is just one measure of variation. Now, the most common, if the mean is the most common measure of central tendency, for the measure of variation naman or dispersion, it's the standard deviation. So, hinahanap talaga ito if you have read researches class, aside from the mean, katabi talaga yan siya always ng mean, si standard deviation. So hinahanap din ito ng mga panelists kasi they have to make sure na the data you have collected are precise. Precise dapat. Hindi din naman natin makikita kung accurate siya, di ba? Kung accurate kasi dapat malapit siya sa true value. That's the meaning of accuracy. Kung nagda-dart ka pa, na-hit mo talaga ang bullseye, that's the time we call your data accurate. Pero kung sinabi lang na precise, if meron kang 3 pins ng dart, dapat magkatabi silang lahat para masabi mong precise. Meaning they are close to each other or they agree with each other. So ito, kung ganito, this is precise but not accurate kasi hindi mo na-hit yung bullseye. Yung target talaga natin sa collected data niyo, dapat andyan sila lahat. Accurate and precise. Pero for the standard deviation, this is just for the precision of the data. And this will measure the distance of the scores from our mean. Okay, remember the mean is the measure of central tendency. It's the center. And we will look at the scores, lahat ng scores, kung gaano ba sila kalayo sa mean na nakuha. So this will measure variability or precision of the data. Medyo mahaba yung computation ng ating standard deviation if you're going to do the manual computation. Okay? Meron actually technique ng standard deviation sa calculator but I'm not really familiar with it. May mga students na alam nila how to get the standard deviation directly sa calculator. Pero mahihirapan tayo pag marami na masyado yung data ninyo. Mahirap na yung 10 lang. How much more kung naging 50 na 100, how much more yung 500. Mahirap ito yung manual computation si standard deviation. Bakit mahirap? Our formula for standard deviation is this one, the square root. Tapos kunin mo of the summation, meaning i-add mo lahat ng scores minus the mean, tapos i-square mo pa. Tapos divided by n is the sample size. So kung 300 yung sample size mo dyan, 300 minus 1. Tapos kung 300 yan, meaning 300 lahat ang i-add mo. Pero kunin mo muna ang difference ng each score and the mean, tapos i-square mo pa. Kaya matatagalan ka talaga kapag marami yung data mo. I will not require you to do the manual computation of this, but I will teach you how to do it sa Excel. Dito tayo mag-end. It's already 6:53. Sa Excel na lang muna, and then next meeting, we'll have the JASP. We close ko pala yung Excel. Kasi 6:53 na pala. Saan ang Excel? Ito naman yung open. Ay, ayun na pala siya. Gamitin ko na lang yung score kanina. Yung potency. We have 10 scores there for the potency. Ito yung kanina, diba? We are done with the mean, median, and mode. Let's have the standard deviation. Standard deviation. Wait, nangyari? Standard deviation. Or the SD. Let's just call it SD. Bahang. Kung sa hapit na mag-end, bahang na siya. Let's have the SD. Ganun pa rin, class. Kung saan mo ilalagay yung score, lagay mo yung green box there and click the FX. And then, hanapin natin si standard deviation. And this one is the standard deviation, I think. Wait lang. Ulit. Not familiar with the codes na ginamit nila dito sa Excel. Ano nakalagay? Estimate standard deviation based on sample. Okay, so this is the standard deviation. Just click that and highlight the scores that you want to test for the standard deviation. And then click OK. And then automatic, this will give us the standard deviation. So sa table nito sa research, i-round off to 2 decimal places. So this will become 4.27. So medyo maliit lang yung ating standard deviation here with our 10 scores for the potency of the vaccines, meaning the data here are close to the mean. And we can say that the result sa experiment is precise. Precise siya. Malapit lang sila. They are close or they agree with each other kasi maliit yung standard deviation. So the most important thing here is you can interpret the results ng computation natin sa statistics. I have an experience with a pharma research na pinaulit sila ng panel, ng mga panelists, as in pinaulit from the start, and that was an experimental research, meaning gumastos sila ulit kasi tapos na yung research pag tingin sa standard deviation. I think the standard deviation is umabot ng 79 that time. That is a very big score for the standard deviation, meaning masyadong malayo na yung mga nakuha nilang values from the mean and very extreme. Hindi ko maalala anong study yun, basta experimental study yun na umabot ng 79 yung kanilang standard deviation. Kung hindi yan siya lalagpas ng 10 or even 20, okay lang yan. Meaning we can still interpret it as precise na data na na-collect. Pero other than that, 50, 70, labaw na 70, 100. Mataas na yan siya na masyado na value for our standard deviation. And most likely, if you will have that values, class, mataas yung chance na ipapaulit kayo with your research. Bakit ganon kalayo yung result, especially for experimental research? Bakit ganon kalayo yung standard deviation? So, kapag may collected data na kayo, pwede kayong magpaunang check with the standard deviation if okay lang ba yung SD ninyo or hindi. Para hindi pa umabot ng final defense, magawa na natin ng paraan. I hope nasundan yun siya. And you've learned something even if limited lang yung time natin. 1 hour lang, it's already 6